and welcome to this edition of the Satellite Image Deep Learning video podcast series. Today I'm talking with Eduardo Siman. Eduardo is the founder and chief hurricane officer of Worldsphere.ai. Worldsphere.ai uses deep learning to improve forecasts for tropical cyclones and other extreme weather events. Eduardo worked for 10 years leading technology teams in the manufacturing, wholesale and e-commerce sectors. Earlier in his career, he was a consultant for the US Department of Defense, and he worked at Goldman Sachs as a private wealth advisor. Eduardo has an MBA from Columbia Business School, where he focused on mathematical finance. Eduardo loves reading Joyce and playing Zelda with his two sons. He lives with his family in Coral Gables, Florida. Without further ado, I give you Eduardo. Hi Eduardo, how are you doing?
Hi, how are you, Robin?
Really good, thanks. Really excited to be talking today about wind speed prediction. So perhaps you can get the ball rolling and tell us what is Worldsphere.ai and what problem does it solve?
Sure. Let me just share my screen. Sure. So Worldsphere is a weather AI company, and the overall mission of Worldsphere is to be able to improve predictions of severe weather events. And that pretty much entails all of the different aspects of those events, whether it be storm surge, wind, uh, massive, snowfalls, whatever it might be. The first area where we're focusing is on tropical cyclones, and specifically on wind speed prediction for tropical cyclones based on satellite imagery. So that's the first use case that we're looking at, and we've done some interesting work there, and then we're building off of that to go to some more sophisticated and complex models that take different more input into account, and that can predict more aspects of a severe weather event, not just the wind speed.
That's really interesting. And that, I'm not familiar with this kind of like weather, but the wind speed itself is significant because it helps people to assess like how much damage is going to be caused, or
right. That's exactly right. So essentially, hurricane strength is measured in different ways, but the Saffir-Simpson scale, which is the one that's most commonly used to try to determine what the strength of a hurricane is, will look at the maximum sustained wind speed. In the U.S., it's done based on a 1 minute recorded wind speed. Most of the rest of the world, it's based on 10 minutes, where it has to be sustained for 10 minutes. But essentially, they have a hierarchy in knots, where if you get to, let's say, 70, if you get to 75 miles an hour, which would be kind of the point between tropical storm and hurricane, and then as you start getting higher in wind speed, you start getting to category 2, category 3, category 4, all the way up to, once you get above 165 miles an hour, that would be category 5 hurricanes.
right?
So
and I'm guessing
now,
they usually have to measure that with like something inside the actual hurricane itself, like on a plane or.
so this is a great question, because one of the things that we always look at in machine learning is, where's the ground truth, right? When it comes to the ground truth in this particular data set, it doesn't really exist until you can have a plane go in there. So before you can have a plane go into the hurricane, the ground truth is essentially, whoever has the most reliable prediction, or whoever is the authority on the topic. So I've used the National Hurricane Center's prediction as the ground truth to compare to, in terms of training the models, and they use a combination of ocean buoys, aircraft reconnaissance, satellite imagery, radar, anything that they have access to, to be able to determine what the maximum speed is. But once you get closer to land, the aircraft recon and the Doppler radar on the aircraft is really the gold standard to be able to say, okay, this is the actual speed, or that is the actual maximum wind speed, because the plane will fly all across the tropical cyclone looking for wind speed across, hundreds of miles. So.
Really interesting. And I guess like I can see it in the title there, where you want to get to is predicting speed. So not just knowing that it's category one now, but that it's likely to be category four or five, in 10 minutes time or something.
Right. That's exactly correct. I mean, right. Being able to say this is what we think the wind speed is based on this, particular satellite image, or even based on this, radar data, is great. But that's something that's sort of, already quite well done. The question is predicting the change in wind speed, and most importantly, predicting change in wind speed over a 2 or 3 day period, when you're close to land. That's
Mm.
that's where, right now, a lot of the meteorological community, that focuses on tropical cyclones, is looking at. That's where a lot of the grants are going. In many cases, it's referred to as rapid intensification, which refers to more than 35 miles per hour change within a 24-hour period. So essentially, an acceleration of 35 miles per hour per 24 hours.
So what we're talking about here is like a time series prediction based off images, where what you really care about is like a single number, like a regression.
Right. It's actually quite fascinating to think about the different ways it can be done, but you can use, of course, regressions. You can use, even categorization is a way of trying to identify acceleration by saying, okay, if I look at these, 10 images in sequence, can I categorize what's the change in wind speed that occurred during the sequence time? So it's not necessarily regression, even though that's the obvious use case. And yes, recursive neural networks and any long short-term memory are obviously going to be very helpful because they're very good for time series, but there are now visual transformers that can handle time series data quite well because they pick up spatial temporal features that were more difficult to pick up in the past.
Fantastic. That'd be an excellent point to start looking at the modeling work that you've done on this problem already.
Right. So why don't we let's just start by looking at some of the kind of the nuts and bolts here, of how you would you know start to model something like this, right? So I mean, look, the first thing that you need is a good data set. So I have my data sets in my Google Drive. I also have them on Google Cloud Storage, so I can import those into Google Colab or anywhere else where I want to run a Jupyter notebook. And I have various different data sets, right? So you can see, I have data sets kind of based on the hurricane and based on the number of images. So in the case of, like this data set here, I have 30,000 different um, images of hurricanes from one particular satellite or a series of particular satellites, that the U.S. government runs. And I also have some, from European government satellites, and Japanese meteorological agency satellites. So, and I have them in different places, and I call up those different data sets depending on what I need to do, right? So, in just to kind of show you quickly how we might be able to do that, I can, basically mount the drive, bring in the libraries that I need. In this particular case, I'm using Fast AI, and you could see here I have kind of different regex parsers. So in this case, it's when I'm looking at files that have 2 or 3 digits and then a space. But other files are different. They have, for example, 2020, 1121, and then they have a time, and then they have another time after it. So in this case, I'm going to use this particular regex parser. So I'm creating a data block using PyTorch and FastAI, and then I'm just going to essentially say, here, what's the path? So I'll just grab the path here, and then and the nice thing is this is really, it's easy to just kind of change what I'm doing from one day to another. So you could see I was working with a data set of meteorological maps, but I could use the same notebook now to deal with a data set of hurricane pictures. Um,
That's
and
cool. One notebook to rule them all. I like it.
and of course, it's having a problem.
Standard
um,
live demos are always like that.
yeah, right.
Doesn't matter. We could just
Uh,
look through the notebook and see
yeah.
how it went in the past.
So essentially here in this particular notebook, what we're doing is we're looking at different meteorological maps. Um, and what I'm doing here is I'm using the date and time to be able to categorize the map. So um, essentially, each date and time becomes a separate category, and and I go through a few different types of transformations. And after going through those transformations, I go and I uh, train the notebook. So let me let me give you kind of a sense for um, what the training might look like.
Just quickly on
Um,
the data, is that single channel data or is it?
so in this particular case, this data is this is just three channels, red, green, blue. Now, typically, what I'm using, because this is a little bit different than what I'm typically doing. Typically, what I'm doing is um, I'm looking at data that is 13 channels, and then I'm generating an image, and that image will be from a particular channel. So in the case of the GOES R series of satellites, I'll generate an image from the channel that looks at the visible data. So I have I have a notebook that where I believe that you can see that immediately. So let's see. Um, so I have all my notebooks are on Google Drive, so that obviously makes it easy for me to be able to find them. Um, if not, then I'd have to upload them or get them from somewhere else, and it'd be quite difficult. Um, so of course, when you're using the fast version, the not the fast, the free version of Google Drive, you can only have one session. I
Yeah.
have tried the paid version, and it's actually there's you can get some very very nice GPU, um, even some premium GPUs. So here you're just basically connecting to your Google Drive account. But you can use if you pay just a little bit, like I paid, you know, $50, and that lasted me like three weeks of training models,
Mm,
which was pretty amazing.
mm.
Um, and the premium GPUs, they obviously take up more time. I mean, they take up more resources, and but it's kind of nice to be able to get really really quickly.
Yeah. So does
Um,
each image have a single wind speed associated with it, or does each pixel have a wind speed associated with it?
right. So each image has a wind speed associated with it. So that wind speed is not actually in the data. Um, so you have to match that up with tabular data that's maintained by the National Hurricane Center. So once you've matched up the tabular data with the image data, you can essentially look for the label by using a regex command like this, or you could say, put them in a bunch of different folders, and then the parent folder, will determine what the label is. So in this case, I think um, this demo might actually work, believe it or not. Um, and I'll be able to show you um, what the process looks like. But I am essentially I'm going to this data set, right, where I have the 30,000 images. These are, from 1978 until 2016. That's the data set that has been really helpful for me, which is it's called the HERDAT data set, which is available through NASA and the National Oceanic and Atmospheric Administration. And at first, I'm just, you want to make sure that the data looks correct and that it doesn't look weird. So obviously, I have some cells that will essentially show me just a few examples of the data, and then once I see that it looks good and that I have the number of records that I expected, that's when I go and do the fine tuning, right? That's when the actual deep learning happens. And like I was saying before, it's when you've paid a few dollars for premium GPU, it really is much faster. So here, this GPU that's allocated just based on free Colab is going to be pretty slow. But if I wanted to do like a premium GPU, I'd have to, pay a few dollars, but not much actually. It's pretty amazing what you can do with $50.
Mm.
And the nice thing, one of the things that I really like about working with Google Colab is you can actually see the execution. So I can click on any part of the execution and actually see what underlying code is being executed as part of the cell, which I think is just really cool. And I haven't really found another kind of IDE that can do that, right? So,
Right.
but yeah, this is taking a little bit of time, which is what happens, right? That's what happens when you're using the free instances, and I definitely don't recommend it for training models because it will kick you out all the time. So, you spend $25 or $50 and that lasts you, good amount of time. So
So
it
pay your
lasted me
50
2 or 3
bucks
weeks.
and you can leave the computer, get a coffee. You're not
Yeah.
sitting there tapping it all the time. Make sure
Very
everything's
important to
safe.
make sure that you change the settings of your computer so that it doesn't shut down, right? Because your Colab instance will shut down. Here you could see, some examples. By the way, there are always going to be cases of weird kind of corrupted data. You see here this 125. That's obviously not a picture of a hurricane. This is one of the things that happens when you go from a netcdf file to PNG. So, these files are all netcdf4 files. And when you're working with, satellite data, as because, you're the expert on this stuff, there's a bunch of different kinds of formats, right? There's like H5, there's netcdf, there's, geotiff, there's all kinds of stuff. And when you convert it and get that one or two different channels, sometimes during that conversion process or during the time that you're using matplotlib usually to do a nice little image generation, you will get weird stuff like this. It's sort of inevitable.
So convert to PNG, visualize, sanity check.
Yep. Then we go through. We basically are going through a few different transformations. So we're resizing, we're padding, which is pretty important so that the computer vision model doesn't think that the edges are more important than they should be. We transform through angle displacement, and then we create some new data. So we're basically augmenting the data just so that we have enough to get a good result. And then we do need TIM. This is something that's fantastic because the TIM library has essentially all of the state-of-the-art computer vision models. So if I go in here and I say, I want to see, every single state-of-the-art computer vision model, Tim will have the vast majority of them, and I can just choose whichever one I want from there, which is pretty amazing.
So you've experimented with a few different models and
many, yes.
Okay.
And I can kind of give some recommendations. And it's unfair for me to take the credit for this. I mean, a lot really I've gotten so many great tips and tricks from taking the Fast AI course. So, I I think that it probably would have taken me 10 times longer to be able to get to a working model without having done the Fast AI course, especially the one that came out in July, because it just gives you some amazing tips and tricks. And even though PyTorch is pretty powerful and it's already quite abstracted up, Fast AI is just another abstraction on top of PyTorch. But
Yeah.
um,
Yeah, I've used it myself quite a bit, and I really like, as you say, the abstraction it allows, and how quickly you can experiment once you've utilized it.
And it's also very easy to send your models to Hugging Face to look at how they've done on weights and biases. So that's one of the things that I really like. It kind of works well with everything. I've also done a lot of modeling with Keras. I really liked the book that the founder of Keras wrote. I think his name is Francois Cholette. And I think he works at Google now, but he's written a couple of great books on using deep learning in Python, and I think Keras is quite easy to use as well. Um,
So you're
so,
using
but
Vision Learner, and your metric is the error rate. So this is a CNN to predict the wind speed for that image. Is that correct?
that's right. So in this case, what I'm doing is I'm actually doing categorization, and that was defined in the data loader. And then I essentially say what I'd like to do is I'd like to use this particular model. This is a Comnex Tiny, was found by Jeremy Howard and the inventor of Tim, which I'm not remembering his name right now. They did some tests on the data set from Planet Labs. So some satellite imagery from Planet Labs, and they found that Comnex Tiny did quite well for satellite imagery. So that's one of the ones that ended up being pretty helpful. And I was able to run Comnex Tiny even on the free GPUs, but the results that it was giving me, and these are some early results that you're seeing here, extremely high error rates. By the time that I was done with this, I was able to get to 4% error rate. But what I noticed was that you could see I ran ResNet and all kinds of vision transformers just to kind of see what they're, and I ran a lot of these. These are the models that are available in TIM. Um, so I in, Inception is one that I tried running as well. It turned out that the one that was, oh, here you're getting to confusion matrix, so I went a little bit too far. The one that was really just fantastic was this Comnext large. Um, this one, this Comnext large, which is trained, on the uh, ImageNet database, but has 22,000 categories. Um, you can't do it unless you pay for a premium GPU. It just
Right.
won't. I mean, it'll take years. But with the premium GPU, I was able to do it in 25 epochs in about 40 minutes.
Cool.
And with the Connex Tiny, I think I had gotten to maybe like a 7% error rate. That's why I think I called this 7%, this particular notebook. With the Connex Large, I got to 4% error rate. That was my best error rate that I was able to get to. Um, and of course, these are categories. So every 5 knots is a category. So being accurate or having an error rate of 0 would mean that you're predicting um, you're predicting that the wind speed is within that 5 knot interval. Luckily for me, the um, ground truth data provided by the National Hurricane Center is actually in 5 knot intervals as well. So I don't have to worry about things like being off by 1 or 2 knots. So
Right.
again, this goes back to the issue with ground truth data for tropical cyclones.
Mm.
It's just not there in some cases. It's kind of like the blind leading the blind, right?
And once you've got all these models and they have their different pros and cons, how are you comparing them all?
There's a couple things that I think you'll find interesting. The first one is just in general what it looks like, to visualize your model within weights and biases. So you can look at the model, and it'll show you the different layers as well as the parameters and the output shape. In this case, what we're doing for this example is a next image prediction, and we're using a couple of convolutional LSTM layers, and then at the end we're doing a 3D convolution. And as you can see, the input parameters in terms of how many images are in the sequence are not defined. So the sequence can be as many images and as many images in the sequence as needed. So it could be, 20,000 sequences of 5 images. It could be 5,000 sequences of 3 images. Whatever it is, it just has to be divisible by the right numbers so that the size of the array stays the same, right? And I can talk a little bit about what are some tricks in terms of doing that.
So weights and biases is quite good to get a quick summary of the model that you're using, and just, I guess, might help with debugging of like issues with like numbers of frames.
If you're doing a Keras model, you can call a summary within your code, but it's really nice to kind of just see a nice graphical summary, and you could see this in addition to all of the other information that I'm going to show you. So, what I like to do here, kind of the runs that I've done specifically, it says uncategorized, but this is my convolutional LSTM runs, and I like to usually sort by validation accuracy, or of course, by loss. So I could, loss is kind of best validation loss is probably the best way to look at it, because the training loss is really not that important. Really, it's the validation set that's important to me. And it creates its own names, which is kind of funny. Some of them are hilarious, like Rich Donkey. Some of them are a little more standard. What I really like about this is that not only can you see all of the real-time metrics for the models that you're running. So you could see here you have kind of the machine learning metrics, training loss, training accuracy, validation accuracy, and you can go into each one of these, right? And you could see at each point, each one of these epochs, where you were at. But in addition, and this is the learning rate, which interestingly enough, you can see a dramatic drop off by order of magnitude in the learning rate around epoch 5 to 10. And that's because I actually asked weights and biases to change the learning rate as I was training the model based on what it thought would be the most effective learning rate.
Is that a weights and bias thing, or is that something in Fast API where you can vary the learning rate?
It's actually, I actually did it through weights and biases. You can do it with Fast AI, and you can do it with PyTorch as well in general, like without Fast AI. But I actually I used a function within the weights and bias library that does that, which I thought.
So when you call a run, because I'm familiar with using it through like Fast API, where you just say, this is where I'm logging, but are you using it slightly differently here because if you're configuring parameters like learning rates through weights and biases? How do you do that?
So let me let's look at an example here if I can. So here you can see here here's a model that I'm actually running right now, and this this is the same model that you saw. It's a convolutional LSTM model, which is trained on a large sequence of tropical cyclone images, satellite images, that were converted to PNG. They were originally in NetCDF4 format. So what you can see here is, you see how it starts here with 0.001. Once it realizes that the validation loss is not going down anymore, so if it has two different epochs where the validation loss is above the average validation loss, then it changes, and now it went to 1 times 10 to the negative 4, right? So now it changed the learning rate, and it'll continue to do that if it thinks that that is going to help the validation loss. So, and we can actually, so just so you can see what I'm actually calling here. So here are the callbacks. There's early stopping, which means stop when you think the validation loss, has reached, its local or global minima. And reduce LR is the function that's part of the weights and biases. Unless I'm mistaken here, and I would love to be corrected because I'm learning all of this as I go along, but maybe reduce LR is a fast AI function, and I just thought that it was a weights and biases function. I wouldn't be surprised.
It looks like it comes from Keras, but maybe it's contributed by weights and biases and somehow integrates, because that would be quite nice to get away from, for some users to get away from modifying APIs to I'm somehow interactively tuning this thing for a UI. I don't know if that's possible in weights and biases, but
you know what? Actually, now that you mentioned it, I'm really glad you mentioned this, because it's not a weights and bias functionality. I think that I interpreted it that way because weights and biases was showing it to me. But if you look here at the reduce LR callback, it's a Keras function. We called our reduce LR on plateau. So it's not even fast AI. It's Keras. In fact, I'm not using fast AI at all in this particular example. Just because I had this model, this convolution LSTM model that was built in Keras, and it was just way easier for me to continue working in Keras, right? So because it's a very simple model, it just has a few conv LSTM layers, and then it has a 3D convolutional layer at the end. So yeah, that's what's happening now, and we can actually go and check out what's going on. We can see in real time. You see this is running. So let's see what's happening. We can see here our GPU power usage, memory allocated. GPU temperature is pretty important. Once it reaches, like 80 or 90, my Google Colab tends to crash. What I have noticed, though, is when I do pay for Google Colab, even if it's $3 for the run, I can get up to much higher temperatures, because the GPU that it's giving me is much better when I'm paying, when I buy credits on Google Colab. So here's our run basically that we just did. It was 10 epochs, validation loss sort of stabilized around 1.02. The learning rate was only changed once, and here's the training loss. And then of course you can see the various system parameters. I mean, it's not surprising that GPU utilization went to 0 when the model stopped training, right?
Yeah.
So
it must be quite convenient to have all of this data in one place and you're trying to understand, like, why did my notebook crash? Or,
Yeah, I mean, what I really like is, look, you can go to the logs and you can actually see what's going on in your notebook, right? So yeah, I could see here that it only went to epoch 11. So why it did that is probably because it just realized it just wasn't getting a better validation loss, and we have an early stopping function. So I have this, and I can so this is logged in here. It doesn't go away. What's even more important to me, honestly, is the files. So I have my my model here, and the metadata, and this is what I can use to then deploy on Huggingface.
Yeah, I think that's awesome. I've had this experience where I just left the notebook and then came back and like it reset and all the artifacts were just gone, and it was very frustrating. I had to rerun it. So the fact that that's
it's horrible.
Kept somewhere externally for you, that's taking care of the responsibility.
Yeah, I mean, it's happened to me all the time on Colab. I mean, Kaggle, it's even worse. It's because it's hard for me. It's harder to understand how to manipulate files in Kaggle. On Colab, at least I can attempt to save it to my Google Drive or to Google Cloud Storage. But this just makes it easier for me. And then there are ways on a Jupyter Notebook or any other Python program to essentially say, move this file from weights and biases to Hugging Space. But sometimes it's just easier to just download and upload. Like, seriously.
Yeah. Cool. So that'd be nice time to hear about how you're using Hugging Face then.
Sure. So what I do is I have here's one of my Hugging Face spaces that this is specifically for the convolutional LSTM. And it's pretty simple. I upload my model. So this is exactly the same as what you saw before, that .h5 format that was generated, which is typical for Keras. Then you have the metadata, which again was given to me by weights and biases. And then there's two critical components. The most important is the app. So, and by the way, there's so many examples out there of different apps on Hugging Face that you can really just kind of choose the one that seems best to you. Like if you look and say pre-train Keras, or you say next image, or video prediction or whatever, you'll find something that probably is 80% of the way there, right? So essentially, here we have an app that it's a fairly simple app. It's just importing all the different Python modules that are needed, and then some important things. It's saying, hey, this is my model, right? There are different ways of doing this. You can refer to the model that you have saved in a model card, and that's something that I've been playing around with, just because I think it's interesting to have a model card, because then it's something the community can use easier than having your model just as a file inside of this kind of repo.
So that's like some markup to describe the model, is it?
Yeah, essentially, I can show you I'll show you what the card is just in a little bit. But what it is essentially just a very small little section where it's only the model, and that's it, and it describes it like you said, and then you can download it, or you can use it. You can use it using functions like this. So in this particular case, I'm actually using my model card by kind of going to this model space, which is the same thing as the model that I have here. I could do it either way. So it's just easier for other people to be able to do it this way, and to be able to say, okay, I'm going to use Eddie's model by just saying from pre-trained Keras, and I just have to reference his model card.
Yeah, so that's a nice Hugging Face API there, just abstracting away, importing a model.
Right. I mean, let me show you. I'm just gonna let's look at so here are my spaces. And then you could see here are my models. So in this particular case, this is the one that I'm referencing. This is called a model card. And 21 people have downloaded, so someone's getting something out of it. I haven't created a README, so that doesn't particularly help. But essentially, I put the license, an MIT license, and then I have the information needed for the model. In this case, it's a little messy because I tried both .pb format and .h5 format, but when you call this, it will call the right information as long as you reference it.
I saw in a tweet there's now a .keras file format as well, which has, I think, quite a nice format. You might want to check that out.
Yeah. I will say
Huggingface is basically like GitHub, but for models.
That's right.
Model, it's in one place. We take care of LFS and all that large file nonsense and give it a README. And then, rather than git clone, it's like use the model from Huggingface.
I mean, and it's so easy. Like you just press using keras, and then this is how you use my model.
Okay. Yeah, it's just a Git repo there, isn't it? Yeah.
That's it. Huggingface is just a gigantic Git repo. In fact, or GitHub repo. You can even give it a star as a even though it's a company that's a repo. But anyways, what I'm doing here is I'm calling this model in my app. If I can find this in my here we go in my app. I'm calling the model, and then obviously for things like next image prediction, there's a little bit more code because you need to basically say like this is what I want the output to look like, and you can define the frames per second. You can, in my case, this is very unusual, but I have a bunch of 50 by 50 images, which is extremely unusual. I mean, because they're not 64, 64, 128, 128. But I knew that I had that. So whatever video you put in here, it's going to reformat it to 50 by 50, because if it doesn't, then the model is going to crash because it's expecting the 50 by 50, which you can see in our model here in weights and biases that it's expecting a 50 by 50, right? So if you don't give it that, it's not happy. That's not normal by any means, and I need to fix that. So what I need to do is when I convert from satellite netcdf file to a PNG, I need to convert it to 64 by 64 instead of converting these to 50 by 50 images. So that's just something that I did that's non-standard, and I kind of try to get my way around it here in the app file. And then what it's doing is, it's basically pulling in the video, which is a video array. In this case, it's an MP4 file, but I've tried this with just being able to put the array, the NPY file, that works as well. And then here's some code for essentially saying, predict the next frame. And here it concatenates the existing frames with the new frame and shows you what the ground truth frames were versus the frames that were created. And then it basically creates a directory where it stores the new file. And then here's the Gradio interface. So the Gradio interface, basically, it's almost like an HTML file saying like, I want it to say video. I want you to have like a slider that has 0.1, 0.9, 0.5.
So Gradio is the framework for making the actual app itself, isn't it?
That's right. Yeah. So, but if you notice the Gradio interface, there's not much code that's Gradio. I mean, this is the only Gradio code that's going on here. It's really the majority of the code here in the app has to do with any kind of pre or post processing of the file to make sure that it looks good or that it's going to work. And you can see here, this is what this actually looks like. Now,
so you upload a video, and I think you can do that through the UI, right? You upload the video, hit predict, and then it will run your code on Huggingface and produce the next frames. That's really cool.
Yeah, I think there's a very important warning here, though. As you can see, this has been running for 2,000 seconds, and this is a 3-second 50 by 50, video of Hurricane Ian, which is
what I mean. That's curious. Do you know what hardware they're using for doing the prediction in the background?
Right. So this is what I found. If I upgrade this, right, so I can upgrade my space. I did this on purpose because I wanted to just show, what's realistic. But
okay, I see.
It's free, 16 gigs. This for video prediction and next image prediction will take forever. Those 3 seconds could take 20 minutes, 30 minutes. But if I upgrade this, and I've done this, I upgraded to T4 with the NVIDIA T4, which was 60 cents an hour, and it was giving me a result in 2 or 3 seconds. So essentially, for every second of the video, it was about that many seconds that it would take to create a result. I never kind of ventured into, something like this. But it's always something that you can give a try.
For a demo for a client, that would be quite useful. And you only pay per minute, so I guess if you go idle and you're not using this thing, you stop getting charged, which is really neat.
Right. So you can actually, and you
can apply for a grant as well. So you could do that if it's an open source project potentially.
Yes, you can apply for a grant if it's an open resource. So it's like apply for a community GPU grant. I have to admit that at the beginning, I was a bit frustrated because a 2 or 3 second video was taking an unreal amount of time. But then, once I was able to just try out, I spent like $1, and I did, I did 2 or 3 videos, and then finally I got the results that I had gotten in my Jupyter notebook, right? So at least I knew that it was giving me what I was getting on my Jupyter notebook, and it was comparing it to ground truth, and it was working. And this slider's kind of nice. You can say when you want the prediction to start. So it could, if you choose it to start way further out, then clearly it'll use all of the images in the sequence. Again, keep in mind this is a little bit wonky because if you look at this particular data set, so this particular data set that I'm using here, you can see the shape of the data set is about 14,400, and each one, no, that's not right. Sorry. I'm looking at the wrong place. Here's the right place. Okay. So here's, coming from my Google Drive. This is my NumPy array, which has all of my images. When I bring it in, it's going to have a shape of around 30,000 images. They're each 50 by 50, and then it's just one channel because it's gray. I actually just got the first 20,000 because that makes it much easier for me to be able to divide in this step. And I can just say 4,000 sequences. Each one has 5 frames in it.
Mm.
And then I can feed that to the model. I struggled a lot at the beginning in trying to understand why the models just wouldn't work with different combinations. Like, I would have 15,000 times 3 or whatever. And what I learned is that when you reshape when you multiply these two numbers, they need to be this. If not, you create complete chaos.
Nobody wants complete chaos.
Yeah.
Right, I understand. That's cool. So once you've got your model on Hugging Face, is that how you're deploying the example on your actual website, your Worldsphere website?
Right. Yeah. So that's how I deploy it on the website. The way that you do that is, by the way, you will have to go through quite a few iterations before this builds correctly. One thing that you have to be really careful of is that you have all the requirements. And there are some places where if it's not the right version, if it's not the version that you built with in your Jupyter notebook, it's not going to build, correctly, because Hugging Face is going to spin up a Docker image that's creating this, and it might have a newer version. So now that there's PyTorch 2.0, that's something to keep in mind. That's certainly happened to me. So the way that I would essentially deploy this, and by the way, I think it's important to know, like, a lot of the heavy lifting here was done by people who created the different elements of this. That's why I make sure to put this space was created by this person. The cares example was by this person, because all I did is just kind of use it for my needs. But I didn't create this from scratch. And I just think it's really important not to pretend like you did, right?
Yeah.
So this is not the absolute best way of giving credit where it's due. Ideally, there should be like a README file that says, I started with this that was created by this person, and then I added this part, and then I started with this space, and then I added this part. But I think doing that just doesn't seem to be very common in the industry from what I can see.
It's not like academia where there's a well-trodden path for citing and getting credit for stuff. It's a bit of a free-for-all in the world of GitHub. And
I will say one thing that I found just looking at some models that have been deployed to Hugging Face is I recognize where they came from, especially because if I'm working with a very small kind of subset, and I'm like, wait, you just use a different data set with space that somebody else created, or but I think that the industry is moving so quickly that nobody's really complaining about it. Like and by the way, I don't want to forget what I had promised, which was how do you deploy this? So you can embed. This is a new functionality that just came out a couple of weeks ago. So you can just say, here's my web component, put it in as JavaScript or as iframe. Super simple. The way I did it before that was available was you say view API. And then here's the API. And then you can call that API from a simple JavaScript, just a simple file inside the website. It's even easier now. Before I had to kind of be like making sure that my little script was calling the API correctly. now it's even simpler because I just say embed the space and it's already kind of telling me like, well, this is how you do it, right?
Yeah, they're really making it nice and simplifying the story around putting like machine learning models into real websites and real applications. I think it's a really good innovation.
No, I think it's great. I mean, I think, you know, this is very much experimental. Like, I think that they want people to be able to, you know, pay more to have this really be like their inference engine. You know, and I think that that's, you know, definitely could be the case. I mean, you know, you can make these private, and you can, you know, have your kind of, you know, intellectual property here, and that could, you know, that could be your inference engine if you want to. But you know, they have a lot of, you know, a lot of competition, obviously, from AWS and Google Cloud, and
I think they're running on AWS, so they're probably pretty cozy, those two.
Right. Yeah, you're right. So
cool. So what's next for Worldsphere, and what's your call to action?
Yeah, so I have been spending the last couple of weeks, honestly, trying to organize everything into a kind of an ML ops strategy. So I've been creating kind of different folders. This is just on, you know, it's in my OneDrive. It's in my OneDrive because I'm just used to Windows. And for so many years, I was a CTO and a CIO. And I just know how to use OneDrive and how to share it with other people. And you know, I know how to set the security parameters. So obviously I have files in Google Drive and Google Cloud as well, but I'm just not that good at working with that. So what I've done is I've said like, all right, let me have all my models in one place. And you'll see that I have models that I've used for different things. Like I have my wind speed prediction, my next image prediction, and I have a model that is for classifying the type of meteorological map. So let's just go, since we're talking about convolutional LCM, let's take a look at it. So you can see here, it's a little bit of a mess, right? This doesn't really tell you what the model does. So my goal is to create naming convention that will link the model here to the weights and biases metadata, and eventually back to the Jupyter notebook and to the data set. So I'm getting there. I mean, I'm making some progress because I can go, I now have like my pre-processed data. So I could say, you know, let me look at NumPy arrays that I've created. So for convolutional LSTM, I'm using these NumPy arrays because it's so much easier than trying to work with 30,000 images, right? So I have this, you know, video array, and I can just import that to a model that will accept the, you know, a NumPy array that is in that format. Now, I also have the original satellite files, that netcdf files, in a different folder, and then I have the PNG files in a different folder. So I'm trying to make sure that when somebody is looking at, you know, exactly what is, you know, Worldsphere doing, that there is a certain level of coherence as to what's going on.
I can see it could get quite complicated. Maybe there's even a mechanism in weights and biases, like for tracking versions of models. Because I'd imagine at some point you don't even care. You just want to look at the metrics and say, "This is my model. Deploy." Yeah.
No, absolutely. I mean, look, for the first few months, I'm not gonna lie, I was a total freaking mess. You know, I was just a total mess. And you know, I started working with a developer in Uruguay. His name is Joaquin, and he's really passionate about geospatial machine learning. And to be honest, he's the one who told me, like, dude, get your shit together, man. And
Right.
he was like, I can't even start developing until I even know what you've done. So that's why I've kind of done this exercise. Really, it's for him and for whoever, and for the next person that joins Worldsphere. And also, I know there's only like a minute left, but for me, I want the company to really be as open source as possible, because the goal is to do something that's going to, really help society, which is help, to predict hurricane intensity. So it needs to be something that can be put on GitHub and that people can look at and they can use for their own projects.
Okay. So if people want to follow your progress, what's the best platform to do that?
I think it's really on LinkedIn is by far the best way.